Hi, I'm John Tagum, and I'm part of Group 10 along with Nicholas Karcha and Samuel Lee. And for our report, we talked about the Carquinez Bridge that was built in 1927. The bridge was the longest bridge west of the Mississippi, spanning 1,100 feet during its time. And the completion of this bridge was important since it stabilized the economy in the surrounding area and allowed it to grow and prosper. When the interstate highway system was implemented in 1956, it introduced a larger volume of traffic, and since the bridge at that time only had two lanes, it wasn't adequate enough to handle the amount of traffic, so a new bridge was built parallel to it in 1958. During this time, they eliminated the pedestrian walkway on the Carquinez Bridge and added another lane. So yeah. As time went on, the bridge standards became more strict on design and safety. So what they decided to do was create a new Carquinez Bridge that was completed in 2000. So we chose to do this bridge, or we chose to do the Carquinez Bridge for our project because it has directly affected Davis, and not only that, but all three of us in this group are interested in the structural aspect of civil engineering, and we wanted to see how structures, especially bridges, affects the surrounding area socially, economically, and environmentally. So now I'm going to pass it to Nick, and he is going to talk about the past design and practice.
Hi, I'm Nick Karcha, and I worked on the past design portion of the bridge. For the Carquinez Bridge, the plans began in 1922, and a man named Charles Derleth was appointed chief engineer of the project by the Rodeo Vallejo Ferry Company. Derleth assembled a team of engineers and experts from a variety of fields to aid him with the project. During the design phase, Derleth conducted 5 studies on different types of bridges he was considering. He completed these studies after 5 months of work, and 2 designs were settled on. The studies left him with a cantilever truss bridge and a suspension bridge. The Contra Costa County Board of Supervisors approved his plans first, and then he took them both to the War Department for approval. The meeting for the War Department approval was held on March 6, 1923, and the plans were approved. Under the condition that they would be reviewed again after more detailed plans were created. When attempting to finalize the design, a debate began between Derleth and his lead designer, whose last name was Steinman, over the final 2 designs. Derleth favored the cantilever truss style because he felt it was safer, while Steinman designed a suspension bridge, mostly because of his admiration for that type. After much debate between the two, Derleth essentially exercised his power as chief engineer and had Steinman work on the cantilever truss bridge, bearing the idea of a suspension bridge. Construction began in April of 1923, and in 1927 the Carquinez Bridge was completed. The final bridge had 2 main spans of 1,100 feet each, which at the time was large enough to be the 4th largest cantilever span in the world and the 2nd largest in the country. The Carquinez Bridge predated both the Golden Gate and the San Francisco-Oakland Bay Bridge, which were both completed in the 1930s. Looking back, the Carquinez Bridge project served as a pioneer for many future improvements in the Bay Area, as California quickly boomed in population, with 2 of the major population hubs only 100 miles away from each other. And here is Sam with the modern portion.
At the turn of the 21st century, the 1927 bridge did not hold up to contemporary traffic and safety standards. As a result, it was decided that a new bridge would replace the old bridge. The new bridge has a suspension bridge design that used steel box girders. Made up of 345 MPa steel, the girder has a total length of 1,056 meters and is located 43 meters west of the original bridge. Its cross-section is 3 meters deep and 29 meters wide. Because of the terrain of the northern end of the strait is higher above sea level than the southern end, the northern anchorage is located on the highest rock bluff closest to the strait. The southern anchorage, on the other hand, is located below approach foundations. Compared to the southern anchorage, the northern anchorage requires stronger foundations due to a difference in elevation. It utilized 380 steel shell piles of 760 millimeter diameter that were driven into claystone material and covered up with concrete. This greatly improved the anchorage foundation and also improved corrosion. The new bridge also implemented a main cable system that extends throughout the span of the bridge to the anchor chambers, where they separate from main cables to 37 different strands. These strands are held in place by the anchor chamber steel rods. This method is highly effective in dispersing load throughout the cables. Compared to the 1927's bridge design, the new bridge design focused heavily on environmental factors that could affect the bridge, such as seismic and wind activity, which are highly prevalent in the Carquinez Strait area. Seismic and wind conditions were tested thoroughly using computer and 3D global models to ensure that bridge will hold up to events of natural disasters. Changes such as refining the steel box girder and removing extra load from the towers and foundations were made thanks to the results of these tests, allowing for an overall stronger bridge design. The 1927's bridge design did not account for the high wind speeds and earthquake activity. Instead, the 1927 engineers focused on the economical prosperity of the area and mode of transportation, which were the most important at the time. I'll give it to John to do the conclusion.
So as you can see, the Carquinez Bridge is an example of how civil engineering has changed over time. Originally in 1927, the only challenge really was for the engineers to create a bridge that could span the Carquinez Strait, and unlike in the future, they lacked standards and regulations, and all they really had to do was choose a design and how to construct the bridge properly. So like I said, in 97 they had more regulations and restrictions. But the new bridge was able to be built quicker because of the new development in technologies and more knowledge of how to design a bridge in general. Looking into the future, there will probably be more regulations and standards. And a big issue nowadays is the impact on the environment and like how infrastructures affect like the environment with like the wildlife and whatnot. So as this trend continues, it definitely is possible to see this redesign for the Carquinez Bridge to accommodate for the environment, at like seeing how it could accommodate for the new eco-friendly vehicles or implementing materials that require less energy to manufacture. So yeah, thank you for listening, and we hope you enjoyed our presentation on the Carquinez Bridge.